My name is Hamado Bamogo, and I am a first-year PhD student at Ki-ZERBO University. My topic is extension of a simple multi-attribute rating technique to group decision problem solving. Please note that I am not very fluent in English, but I will do my best to communicate. Thank you for your understanding. To start off this presentation, we will address the following points. First, the context and problems, then the objective, the methodology, the application and comparison, finally, a conclusion. Let's start with the context and problems. In modern organization, decision-making is often a collective process involving several stakeholders. Group decision-making is a common practice in organization in expert committees involving the collaboration with several decision makers for a common decision. In the literature, there are several decision support methods, but they are often controversial. The SMART method is widely used in the literature, but in the context of a single decision maker. How can we find a collective aggregation function on the basis of SMART with good properties? Now, let's look at the objective. To address the previous question, we propose extending SMART to a group decision-making context by incorporating preference aggregation mechanism. The extension of a SMART method to group decision-making represents an innovative contribution to the field of collective decision-making. Now, let's look at the methodology. Principle of new method, Mark SMART. The principle of new Mark SMART method is based on the use of two specific operators to aggregate information from group members into a global preference matrix. The exponential logarithmic mean. The exponential logarithmic mean is defined by the relation 3.1. The weighted order weighted average, WOWA, is an operator that uses a weight vector P in R to the N for the criteria. It is defined by the relation 3.2. Description of Mark SMART. Step 1, determination of the global weight of the criteria. In this section, we calculate the global weight W sub j of each criterion C sub j based on the previously defined B sub k operator, given by the relation 3.3. Step 2, determination of the global evaluation of the alternatives. To calculate the global performance G sub ij of alternative A sub I with respect to the criterion C sub I, the following procedure is applied. This gives us the global performance matrix D as shown below. Step 3, formation of the global preference matrix. In this section, we form the global preference matrix denoted D sub G, presented by the relation 3.4, based on the matrices W and D. This gives us the matrix D sub G, given by the relation 3.5. Step 4, application of SMART of a global preference matrix. In this step, we apply the SMART method to the global decision matrix D sub G. Now, let's look at the application and comparison. The problem is to determine the best care center of severe cases of COVID-19. For this, we have 4 centers, center 1, center 2, center 3, center 4, 5 criteria, 3 decision makers. The decision makers matrices are given below. The table 4.1 represents the matrix of evaluation and weight of the decision maker 1. The table 4.2 represents the matrix of evaluation and weights of the decision maker 2. The table 4.3 for the decision maker 3. Max Math resolution. Step 1, determination of the global weight of the criteria. Using equation 3.1, the global weight W sub 1 of criterion C sub 1 can be easily calculated. Let us consider a small k equal 0.1 to reduce the influence of extreme values. We get W sub 1 equal 6.89. Similarly, the other global weights are obtained forming the following global weight matrix. Step 2, determination of the global evaluation of the alternatives. Let us calculate the global performance G sub 1 of alternative A sub 1 with respect to the criterion C sub 1. We get the global performance G sub 1 equal 6.368. We also have the global performance G sub 2 G sub 3 G sub 4 Similarly, the global performances G sub I, J are calculated. This gives us the global performances matrix D presented in the relation 4.2. Step 3, formation of the global preference matrix. From W and D, we form the global preference matrix D sub G presented in the relation 4.3. Step 4, application of SMART to the global preference matrix. Normalizing of weight. Normalization of weight. By normalizing the vector W, we obtain the vector W hat given by the relation 4.4. Calculation of utility values. The utility value is determined based on the nature of the criteria. Utility values are calculated according to 4.6 and 4.7, 4.6 and 4.5. In this problem, we have 5 criteria. 4 are beneficial and 1 is not beneficial. The relation 4.5 and 4.6 allow us to obtain the utility values matrix presented in the table 4.4. Calculation of weighted score. We calculate the weighted score based on equation 4.7. This gives us the table 4.5. Aggregation of the weighted score. We aggregate the weighted score based on relation 4.8. This gives us the table 4.6. Now, selection of the best alternative. In this final step, we select the best center based on equation 4.9. It follows that center 3 had the highest score, making it the best center for handling severe COVID-19 cases. The ranking is given by the table 4.7. Comparison with MAC-ASP and MAC-ASP. This problem has been solved in the literature using methods such as MAC-ASP and MAC-ASP, yielding the following result. The table 4.8 represents the score of ranking by MAC-ASP. The table 4.9 represents the score of ranking, the score and ranking by MAC-ASP. The ranking of the center using the three methods is summarized in the following table. The table 4.10 represents the ranking of center by the three methods. The centers are ranked in the same way by the MAC-ASP and MAC-ASP methods. However, with MAC-SMART, there is a slight disparity in the ranking. Center 1 and Center 2 have swapped position, while Center 3 and Center 4 have maintained their rankings. Now, let's look at the conclusion. The MAC-SMART method applied to group decision-making problems represent a major advance in the field of collective decision-making. The value of this extension lies in its ability to make the decision-making process more inclusive, transparent, and of higher quality. The prospect for this extension are multiple. Extend to more complex contexts, improved aggregation method, ample validation. This perspective will enhance the robustness and applicability of the MAC-SMART methods. Thank you for your attention.
Thank you. That was really interesting. And I'm going just to facilitate the process, add also my question in the chat so you can see it as well. I see that your method demonstrates significant potential for collaborative governance. Do you see its application in sectors beyond healthcare? How do you foresee further applications of this methodology?
Can you speak slowly?
I'm sorry. Yes, this was a great presentation. Are you thinking to use this method in different fields, like in health, government decisions?
No.
What kind of applications were you thinking to use it?